In this video, I'll explain Tresca's yield criterion. Okay, this is the first of the two yield criterions in combined shear stresses and normal stresses. So, going back to the original strain and stress curve we saw a few topics ago, for such a metal experiencing just uniaxial tension, purely loaded in tension, if we draw the stress and strain diagram, we get a diagram that looks like this. The initial section is the elastic region, the second is the plastic, followed by plastic we had strain hardening, then necking and failure, which can be seen by the specimen in the middle here. Now the yield criterion in uniaxial tension is by itself just the yield stress, nothing else, just the yield stress by itself. Now what happens if we have combined stresses? Okay, so on the other hand, a material experiencing normal and shear stresses will require a combination of stresses to yield. This combination of stresses producing yield is known as the yield criterion. Okay, so we need to assume that the material is ductile and isotropic so that this yield criterion work. Now the first yield criterion is known as Tresca's criterion, and the parameter, the vital parameter, and it's based on the maximum shear stress reaching some value of some critical value. Okay, so Tresca's criterion is the first of the two criterions in combined stresses, and I'll explain the second one in the next video. So moving on and continuing with Tresca's, in uniaxial tension, this is the following situation: a Mohr circle for an element in uniaxial tension. Now looking at this, we only have vertical normal stresses Fy and no horizontal vertical stresses. Okay, and we have shear stresses that are equal to 0. Okay, so the properties are